Hello, favorite people. The best day of the year, February 3rd, and it's the longest. It's 364 days before I have to think about those groundhog fools again. This is the best day of the year. The air is fresher, the sky is bluer. Oh, I just love it. So, let's take advantage of this great day. Smart people back in the world again and get to it. If you will, please pause here. 2 questions for what should you be forgetting today. I need you to pause. I need you to work those out on some scratch paper for yourself. And you will need both of these for the lesson today. So make sure they're done in a way that you can look and understand, and unpause when you're ready to go. All right. Put that aside for the time being. Well, actually, don't. We're going to come right back to it. You can leave it there. Today, I want to teach you how to create equivalent expressions by combining like terms. New thing to do today, combining like terms. Before I do, we've already learned how to create equivalent expressions by factoring and using the distributive property. We've kind of done this to death. If we take an expression in this form and switch it to one in this form, we call that using the distributive property. If we take one that's already in this form and we put it back in this other form, we call that factoring. And that saved us from having to do all that business. If then, what's x, what's the expression equals. So that was one way we could create equivalent expressions, and we're going to do another today. So what about this? This was the second thing I asked for you to do in what should you be forgetting today. We don't really have any tactics for this other than to check it. So let's do. If x equals, then, and here, if x equals, so then, let's see if my work matches yours. To know if these are equivalent right now, that's our only real thing we can do. If x equals 0, then this is 0 plus 4 plus 0 plus 3, 7. X equals 1, this is 1 plus 4 plus 1 plus 3. X equals 2, this is 2 plus 4 plus 2 plus 3. X equals 3, that's 3 plus 4 plus 3 plus 3. And that's usually enough. So I'll stop there. Let's check this one. If x equals 0, I've got 2 times 0, which is 0, plus 7 is 7. If x equals 1, then I've got 2 times 1 is 2, plus 7 is 9. If x equals 2, then I've got 2 times 2, which is 4, plus 7 is 11. And if x is 3, I've got 2 times 3 plus 7 is 13. And sure enough, those are equivalent. And that's a lot of work, though, just to tell if those two things are equivalent. So I want to talk about using the other kind of method where we turn one into each other today. And that's what we're going to do. So I'm going to teach you to create an equivalent expression rather than just check them by what I call combining like terms. Here's how we do it. So I'm going to take this one you've already done. And notice now I don't give you the second one, though it turned out, if you want to remember it, to be 2x plus 7 that it was equivalent to. But if I didn't give you that, and I wanted you to turn this into another expression that's equivalent, a simpler one like this, here's how I would do it. 2 ways. One, I might do a visual way. So I might draw all this stuff. So I would have an x, a 4, another x, and a 3. Or you might do an x, you might do like 4 this way, an x, and 3 this way. You can do dots, or you can just do the number. And notice all of these are added. Add, 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 add. Add just means like put it all together. I'm going to go ahead and just use one of these so I don't get confusing, right? So if I add these, all I really do is I imagine like putting them in a bag together or putting them in like a box together and kind of like shaking them up. And so if I do that, I can look in here and say, well, I can do something, I can put some things together. Like I can put these x's together. They're added, and I can put the numbers together. And so if I do that, If I put the x's together, I would have like x plus x, which is the same as 2 times x. I have 2 x's. And I have the 3 and the 4 could go together and make 7. If I do that, that's called combining like terms. The 4 and the 3, which I've circled in green, are like terms. They're both numbers. And the x's, which I've circled in red, are both variables. They're like terms. So when you combine them, you can do this. And that's a much simpler expression, 2x plus 7, than this one. If you don't do the visual way, the other way you can do this is with what we call the commutative property. I'll explain what that word means in a minute. This is not too bad, though. So I'm going to write the original expression down here. And what I'm going to do, again, since everything is added, it doesn't matter what order you add in. Adding and multiplying work in that way, where if you reverse the order, you still get the same thing. So what I'm going to do, I'm going to reorder this by putting the x's together and putting the numbers together in my order. That's called using the commutative property. All the commutative property means is a fancy way of saying I'm rearranging them since they're all being added. Commute means like move. You hear your parents or somebody talk about commuting to work. It's like driving to work, So commutative means move. And now when they're together, it's easy to see like, okay, these are like terms that should go together. X plus x is 2x. There's 2 of them. And these are like terms. The 4 and the 3 I can add together. And either way, I get 2x plus 7. I've created an equivalent expression by combining like terms. Here's a more advanced one. Create an equivalent expression to 3y plus 6 plus 2x plus 9 plus 10y, by combining like terms. So 2 ways I can do that. I've got a visual way, and I've got a commutative property way. I'm going to do both. You, of course, can just master one, whichever you prefer. So I'm going to start the visual way. I literally like draw all of this stuff. 3y, 1, 2, 3, and a 6, and 2 x's, and a 9, and 10 y's, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I literally just imagine adding them all together, putting them together like they're all in like a bag or a bucket or something. And I can just take them out and order them as I feel like it. So if I put all that stuff together, now I'm going to combine the things that go together, which we call like terms. I'm going to combine like terms. So I would say all the y's can be combined. There's 3 here and there's 10 here. So altogether there are 13y. The numbers can go together. Notice I like to change colors when I use different terms. So I could put the numbers together in the same place. The 6 and the 9 together would make 15. I can't combine the x's with anything. They don't go with the y's because they're a different variable. They might be different numbers. And there's no other ones to combine them with, so they're just going to kind of stay like that. And after combining like terms, I took this fairly complicated expression and I turned it into one that's a bit simpler after combining like terms. If I use the commutative property, similar thing. I also like to use color here, so if you've got that, be ready. So here's my original expression. And what I'm going to do, everything's added. You can't do this unless you verify you're only adding. But I am adding all of these things together. So what I'm going to do is I'm just going to put the things that ought to go together. So when I rewrite this, I'm going to put the y's together. Notice I'm just rearranging my terms. Then I'm going to put the x's together. There's only one set. And I'm going to put the numbers together. There's 2. And you'll notice I just rewrote it the same way. Doing that, that's called using the commutative property. Commutative property says if you're adding stuff, you can do it in any order you want, and it won't change the answer. Now I'm ready to combine like terms. So I can combine the y's. 3y and another 10y are 13y. nothing to combine the x's with. They're just going to stay as because there's no more. And I can combine the 6 and the 9 to make 15, and you'll notice I get a match either way. All right, let's do one for your notes. Take out your we do example and let's work it together. You're welcome to pause it here, work it on your own, and see if you're right. You're welcome to work it as I work it, like listen a little, pause, listen a little, pause, listen a little, pause. Or you're welcome to just listen, and when I'm done, write it down like we normally do in class, whichever is best for you. Okay? So, visual, all I'm going to do is I'm going to draw all of this in here. I'm just going to write down what I see. I see 3x, I see 6, I see 4y, I see 5, and I see another y. If you don't see a number in front of it, there's just one. It's a y plus y. And all that stuff just kind of goes together. I imagine like putting it together and like shaking it up in my hands or something, and then I like separate it out based on what I see. So there are 3x in there. There are 5y in there. And there are 11 just numbers in there. And I get a simpler expression like 3x plus 5y plus 11 if I draw. So notice that's just a simpler way to do the same thing. If I were to do my if-then table, they would match. Commutative property, I start by writing the whole thing out. 3x plus 6 plus 4y plus 5 plus y. From there, I start to look for things I would like to combine. If I have colors, I underline them in different colors. If I don't, I kind of do this. I kind of say, okay, I could combine the y's, I'll underline them. I could also combine the numbers, I'll maybe like squiggly underline them. Some way to tell me they go together. I often just use different colors too, like I might underline y in green, and I might underline the numbers in red or something. Doesn't matter. Just some way to like orient myself that they go together. And now I'm going to rearrange. This is called using the commutative property. I'm going to put them where the things that I want to go together are together, because I can do that since everything's being added. So I'm going to put the 3x, I don't have anything to put with it. The numbers can go together, and the y's can go together. And now that the things that go together are together, I can finish up by combining those and combining those, and I'll have a nice expression. I can't combine the x's with anything. Sometimes that's the case. The 6 and the 5 together make 11. 4y plus another y, 4y plus one more y, make 5y. And you'll notice these match. Check. Smiley face, yay. Either one is totally fine, whichever one you prefer to do. Y'all, that is how you combine like terms with the distributive property. I have you do together and you do alone coming up next. Hope this makes sense. If it didn't, or if you found yourself tuning out or doing something else and you're worried that you're not going to understand this when the time comes, just go back and watch again. All are part of it, and get caught up. Make sure this is your notes, and when they are, you're ready to move on to the next thing.